Mr. Kalyan Ram. He is co-founder and CEO of Electrono Solutions Private Limited. He provides strategy and insights, drive innovations, defines organizations' business goals, and ensure business development. Having more than a decade experience in the field of control system design and remote engineering involving Industry 4.0 solutions, he also head the engineering design team at Electrono Solutions. Mr. Kalyan Ram is also the president of International Association of Online Engineering, Austria. Coming from an engineering background, he has a master's in embedded system design. Today, Mr. Kalyan will give us a brief view on IIoT, a gateway to increase OEE. So delegates, let's welcome Mr. Kalyan.
While I run through this presentation, this could be the approach. We'll talk a little about what we do at Electrono, what is manufacturing excellence, how Industry 4.0 gets quantified into digital transformation solutions, and some of the success stories which we have come across, which translates into outcome and result. Electrono, we started in 2011. Most of you might be able to recollect that 2011 was not even the time when Industry 4.0 as a word became popular. We started with the term remote engineering, and because prior to this starting Electrono, I was working with Fanuc for a while and then also GE in control system design. We have been identified as one of the largest implementers of Industry 4.0 solutions with over 2,700 plus assets connected and ranked among the top 10 best IoT companies in India.
Mr. Kalyan, sorry to interrupt you. Hello, Mr. Kalyan.
Our solutions have been
Hello, Mr. Kalyan.
across several of the OEM customers such as
Hello.
Honda, Toyota, Mahindra, Hyundai, Indian Railways, amongst others.
Yeah.
So here we are with that brief introduction. I would like to touch upon how Industry 4.0 and specifically Industrial IoT, which is a component of Industry 4.0, would remain to be a gateway to increase overall equipment effectiveness. But before we get to OEE, it is appropriate for us to touch upon what exactly OEE consists of and how OEE is connected to manufacturing. Talking about manufacturing excellence being an objective for any manufacturing company, there are four major verticals, starting with production, maintenance,
Mr. Kalyan?
quality, and subsequently sustainability, safety, security, and compliance. Let's focus right now on these three main pillars called production, maintenance, and quality. Production is measured by the amount of parts produced, or in case of discrete manufacturing, and the throughput in case of process industries. Maintenance is defined by technically the amount of time your equipment is up and running versus the total amount of time available. And quality is defined technically as the amount of accepted output versus rejected or reworked outputs. Keeping this in perspective, if we take all the three metrics, which is productivity or production, which is total product produced divided by the total number of parts produced, maintenance, which is the total time of the availability of individual equipment versus the total amount of time available, and quality, where the number of accepted parts divided by the total number of parts. If you get all these three parameters and then multiply them, now this becomes a very, very stringent parameter. Imagine having a system where your productivity is 90%, which means out of the total amount of planned time of production, 90% of the time you ended up producing the parts. But imagine if your availability also then becomes 90%. Now the product of these two will lead to 81%, 9 into 9, as you can know. So that means your effective OEE started dropping. And then if you start multiplying the same 90% of quality, then you become 72%. So that is why this becomes very, very stringent parameter. Several elements of Industry 4.0 constitute several things to many technology enthusiasts. You might already have come across several of these. In our perspective, we focus on IIoT today. There are many, many elements, but we focus on IIoT today, which includes addition of smart sensors, connection to controllers such as the CNCs and PLCs, And all of this is being done to define the data sources, aggregate the data, validate the data, and come up with this one metric called as overall equipment efficiency or effectiveness. Well, there are several challenges historically in the digital transformation journey. It is about unplanned downtimes, lack of visibility, lack of flexibility, and identifying the operator limitations, um, and also agility. And this is going to result in several situations where your downtime losses would be of a certain value, and you have waste leading to due to an amount of rework or rejections, and also a lot of manual involvement leading to both erroneous outputs and also increased time consumption. While just giving an introduction of what are the types of data sources, the primary objective of industrial IoT, unlike its predecessors such as the MES platform referred to earlier, is to facilitate real-time data directly from the controllers or devices or inspection equipment without having any human intervention, which means we do not prefer operators or line supervisors to have some sort of a interface where you start entering data. Many a time, several people misunderstand digitization to translating a paper-based check sheets into a tab-based check sheet. Well, that could be step one, but that is not the oblivion, that is not the ultimate. So the objective of industrial IoT is to facilitate the data sources, facilitate the data from data sources directly, such as the CNC controller that you can see here, or the gauges, or the PLC controllers, or any of the digital devices that are accessible. And typically, to achieve that, the architecture could go like this. On the right side, you can see the different types of assets. You've got machines, you've got overhead cranes, you've got hydraulic and pneumatic systems, robots, STP, ETP plants, chillers, transformers, silos, storage devices, compressors, and so on and so forth. So, a manufacturing facility has many or all of these, and the objective is to connect them into a network and then transfer that to something called as the IoT interface. A place where it will understand all the necessary protocols and connect the systems into a central data infrastructure. Subsequently, you validate the data, you analyze the parameters, and involving multiple types of algorithms, could be machine learning, could be deep learning, and subsequently pass on the data to a different type of representation or visualizations, data storage into multiple historians or some sort of historical data retrieval systems, or external tools such as ERPs and other systems. While all of this happens to be an important element, ultimately the objective, at least in this context, is to come up with something called as real-time determination of overall equipment effectiveness. As you can see in this picture, this is one layout of all the machines, in this particular case, 46 odd machines, and you can clearly see in real time how this data representation happens, and how the predominantly the operational OEE comes into picture. This operational OEE can be analyzed and integrated over a period of time to obtain the shift-wise OEE, day-wise OEE, weekly OEE, monthly OEE, and so on and so forth. In addition to OEE, while you can notice here OEE involving the time of operation, the number of parts produced, and also the quality of the produced parts integrated into a computation of the overall equipment. As we know that, as I mentioned some time back, so availability becomes one of the first elements. The process of facilitating availability is predominantly the responsibility of maintenance departments in most of the manufacturing. So it becomes very important to anticipate failures, understand the failures, identify the nature of failures, and ensure that during your typical shift operating times, you would not want to have your machines down. So in order to do that, you might end up predicting several situations which can cause the downtime on the machines and ensure that you take appropriate actions during the scheduled downtimes, which could be a Sunday kind of a thing or a holiday, or in fact an organized scheduled downtime to maintain a machine or a machine system. So this would be one of the key contributors in order to ensure you're going to have a very, very effective improvement in your overall efficiency. As you know, as the bathtub curves of reliability engineering states, as the age of the machine or equipment, especially having moving parts, keeps increasing, the probability of having a failure or downtime also keeps increasing. So the idea here is to ensure that instead of going in a firefighting mode after having a breakdown, running behind the machine and fixing it, the objective is to ensure that you don't end up in that situation at all. Of course, there are several entities that translate into a lot of information that I might want to communicate. But due to paucity of time, I would jump straight into the production side of it next, which is defining the actually produced divided by the target, which gives you approximately the amount of production done and also translates into the element of OEE. This is some set of graphs which gives you an estimate about how the OEE has been translated across the shift, across the day, and what are the key performance indicators accordingly, and some additional information on how you can actually estimate and predict a given set of failures. So this is a dashboard which is having some sort of real-time information representing OEE on one side by defining the three elements. Of course, this is representative. This is not the actual dashboard. You can see all the numbers are the same. So I'm just giving you a representative information of how this is going to be defined. Of course, you can also have the same information on multiple form factors, such as your mobile phone, tabs, or even full-fledged computational platform. With this, I would quickly jump onto a quick video. I think I have about 1 more minute. I will just take you through the video very quickly to show you how the computation of OEE happens and how it is driven across, starting from all the way from the work order release through the ERP system and defining the sequence of quantity to be produced. And this is the Pareto, which represents the OEE technically. As you can see here, the OEE computation happening, and with some level of computation of OEE across the day, across the month, and so on and so forth. So with this, I come to the end of my introductory discussion.